Okay, all right. Now time for the tough question. Here, first I start you off with two shapes here. I've even named them for you. Cylinder, yay, and a cone. We're gonna find the surface area of the cylinder and the cone. First, I'll start with the cylinder. Here's the formula, again, a formula that's given to you. You don't have to memorize. Here, 2 pi r squared plus 2 pi r h. Remember, r is our radius, h is our height. Radius, height. All right, so now I just plug it in. So what do? Plug it in. So I put 2 pi r, my radius is 5. Put that in parentheses just to be nice and neat. Squared plus, and then I have 2 pi r, my radius again, that's 5, and then times the height. And the height is 4. There we go. Let's see if we can simplify this baby. Here, so 2 times 5 squared. 5 squared is 25. I promise you. I don't lie. I never lie. So 2 times 25 is 50. So I have 50 pi. Remember, pi is delicious. Let's try to keep it in terms of pi whenever we can. So then this side plus 2 times pi times 5 times 4. Keep it in terms of pi. So 2 times 5 is, carry the 3, 10 times 4 is, carry the 3, okay, 10 times 1, 40. So I have 40 pi. Now look at this. 50 pi plus 40 pi equals 90 pi. But once again, what are we not supposed to forget? We are not supposed to forget our units. So what do I write here? Feet, and then surface area. Is that squared or cubed? Area is always squared. Feet squared. Now for the cone, surface area here, pi r squared plus pi r l. L, that stands for lateral, the lateral height right here. 6. It's lateral because it's the height of the side. There we go. So now again, pi r squared, my r is, I'm so confused. The whole thing is 4. I just want the radius. So I guess that's called the, what is it again? The diameter. So give me half of that. Half of that will be the radius. So pi r squared, r is half of 4, so that's 2. 2 squared plus pi, again, radius is 2. 2 times our lateral height, 6. So let's look at this. 2 squared, 4. We got 4 pi now. Keep it in terms of pi because pi is delicious. Plus 2 times 6 is, I'm going to carry the 3, 12. So 12 pi. Once again, keep it in terms of pi. So delicious. So 4 plus 12, 16. I promise you, I don't lie. 16 pi. Now, what am I not going to forget? No, not your birthday. The units, centimeters squared, because it's area. So now, on for the tough part. What if I put these two shapes together? I want to form something nice and fun. Look at this. Boom, boom. I'm going to put these two shapes together, and let's see what happens. So I've got my cylinder. I'm going to go ahead and move them up here. Oh my gosh. Oh my God. Oh my God. Look what I just did. I just made a shape. I put two shapes together, made a new shape. It's called a composite. Remember? Composite. So now, this one's a little tricky. This is what you have trouble with. So first, what if I wanted to find the volume of this shape? What would I do? This one would be easy. I just take the two volumes of each shape and I just add them. You see that? It'd be this plus that. So however much, like let's say water, or what do you like, Mountain Dew? However much Mountain Dew I can put in this cone, plus however much Mountain Dew I can put in this cylinder. I put it together, add my volumes together, and that'll be the volume of this composite shape here. But now, the tricky part is the surface area of this shape. Now I want you to think about this logically for a second. Surface area is the area of that part of the shape on the outside there. If I'm putting these two shapes together, let's see, I'll take it apart again. If I'm putting these two shapes together, That means I'm covering one face on each shape. I'm going to be covering what? I'm going to be covering this part here and this part here. I'm covering that. Now, if I cover that, can I find the area of something I don't see, something I can't see? No, I can't. So I need to take that out of my formula. So what shape is this? That's a circle. So take the area of this circle out of my formula. So my formula here is pi r squared plus pi rl. Pi r squared is the area for that circle. Since I can no longer see it, get rid of it. And look at this one. I have 2 pi r squared because I have a circle on top and a circle on bottom. But the circle on top is being hidden now because I just put this guy on top. He's covering that circle here. That's why I shaded him in. Like this one's not, we don't care. We can't see it. How am I supposed to take the area of something I can't see? So what I say is, okay, let's take a pi r squared out of this formula. Here I have 2 pi r squared. So let's get rid of one of them. There we go. So now what I'll do to find the surface area of this composite shape, remember composite, putting them together, would be this. Let me change that color. I would say this plus this here. So what I'd have here is, you see how I have a 2 right here? Well, no longer will have a 2. I'll get rid of that. You see this one here? I no longer have a pi r squared. So to find the surface area, of this composite shape, I will be taking this plus this. Easy peasy, lemon squeezy. Don't fret about it. Don't worry about it. Forget about it.